Hello everyone. Now I am going to start next instruction from data transfer instruction. So it is a LDAX. It is opcode and operand is B/D register. B/D means it is a register pair, means either it is BC register pair or DE register pair. So the meaning of LDAX here, LD stand for load the data, A stand for accumulator and X stand for register pair, which is mentioned here, BC or DE register pair. Description: load accumulator indirect. That means the content of the designation register pair point to a memory location. That means BC or DE register pair, it points to a memory location. This instruction copies the content of that memory location into the accumulator. That means the content of given memory location is copied to accumulator. The content of either the register pair or the memory location are not altered. Example like LDAXB, or we can say LDAXD. There is only two register pair, BC or DE. Next, similar instruction set is a STAX. In the previous instruction, as we earlier told, the meaning of this instruction is ST stand for store, A stand for accumulator and X stand for register pair. The register pair, as the previous discussed, B/D. Store accumulator indirect. So the content of accumulator are copied into the memory location specified by the content of the register pair. So one instruction is used to load the data from the memory location into the accumulator, and this one instruction is used to store the data from the accumulator to the given memory location. So one instruction is used for read operation, and this instruction is used for a write operation. Let's take an example. Let's suppose we have address at 2030H and 2031H. And here in this memory we have a 20H and 56H. So if we write the instruction LXIB 2030H, first we have to initialize the register pair, either it may BC or DE. So after executing of LXIB 2030H, it becomes in BC 20 and 30H. After that, if we write the instruction LDAXB, so as previously told, the meaning of LD is the load. LD is the load the data. A stand for accumulator, X for register pair, B means from BC register pair. So here in BC register pair, BC is 2030, and in 2030 the content of in 2030 is 20H. So that 20H is copied to in accumulator. Let's take another example. Let's suppose we initialize the LXID 2031H. So after executing this instruction, the DE become 2031H. Then if we write LDAXD, means LD stand for load the data, A stand for accumulator, X for register pair. So here D stand for DE register pair. So it's previously initialized in DE 2031H. So in 2031H, here is a memory of 56S. So that 56S copied to accumulator. let's take another example for STX. Let's suppose again we initialize the LXID 2032H. So after execution of this instruction, the DE becomes 2031H. So if we write STAXT, that means ST stand for store, A stand for accumulator, and X stand for register pair, D stand for DE. So what is the DE? DE is 2031H. So, and what is the content of in D? A accumulator, it is 56H. The content of accumulator is 56H. Why? Because it is not altered. So in STAXT, after execution of STXT, in 2031H, the content of accumulator is copied to in this location. So it is the example of LDAX and STAX. Here there is a problem. We can explain with the help of this problem. So write a program to transfer a data from one memory location to another memory location. So it is a problem statement. Let's suppose we have an address 2040H. It's a random. It may be 2040H, and here the data is 32H, and we have a 2041H. Here the data is 56H. The content of these memory location is transferred or copied to in 2050 and 2051H. So we have a lots of options to write a program for this problem. So first we are using solution using LDA-STA. As we previously discussed about the LDA and STA. So first we have to load the data from given address. So we write the instruction LDA 2040H. So after executing of this instruction, LD stand for load the data, A stand for accumulator, from where 2040. So in 2040 it is a 32H. So after execution of this instruction, A is loaded with the 32H, right? So once the data is loaded in accumulator, so we have to store the data in 2050H. So we write STA 2050H. So after execution of this instruction, meaning of STA, that means store the data in given location. So after execution of this instruction in 2050, it becomes 32H. Again, for next memory location, we have to write LDA 2041H. So here the L2041H is 56H. So after execution of LDA 401H, here A is copied with 56H because in 2041H have a 56 memory content. So once we have a data in accumulator, then again we write instruction STA 2051H. So after execution of this instruction 2050H it becomes, it is 2051H. So 2051H is 56H. Then HLT. HLT is halt. Halt means stop the program. So it is the examples. We can use another set of instruction for rewrite of this program. So try the problem with the LDAX and STX, and also you can try with LXI, H and MOV move M, A or other instruction. So we can discuss this program in our next lectures. Next instruction LHLD 16-bit address. Here opcode is LHLD and operand is 16-bit address, and description load the HL register direct. So the meaning of LHLD, L stand for load, HL stand for in HL register, D for data. So this instruction copies the content of the memory location pointed out by 16-bit address into the given register. It copies the content of next memory location into register H. Means it take two consecutive memory location. The first memory locations, whatever the content have in the first location, it is copied to L and it automatically incremented by 1. Then the next memory location, whatever the content of next memory location, is copied to the H. Example, LHLD 2040H. We take another example. Let suppose we have a 2070 in 79H and 2071H is 98H. Remember one thing, we are taking a consecutive memory location. That means if 2070, that means 2071. If we write LHLD 2070H, so after execution of this instruction, the content of 2070H copied to L and the content of 2070H is copied to H. So after execution of this instruction, in HL becomes 98, H is copied to H as we H, and in L it is 79H. So it is an example of LHLD. Same as LHLD used to load the data from the memory location, it is similar to the SHLD. It store the data into the memory location. SHLD, it is opcode and operand is 16-bit address description, store HL register directly. So S stand for store, HL means HL register, D for data. So the content of register L is stored into the memory location specified by 16-bit address, and the content of H are stored into the next memory location as we discussed previously. So example like SHLD 2550H. We take another example. Let's suppose we have in H 34H and in L 79H. So after execution of SHLD 2060H, let's suppose. So after execution of this instruction, the content of L is stored to 2060H. Sorry, it is by mistake written. It is 2060H. The content of L, that means 79. The 79 is copied to 2060, and it automatically incremented by 1. That means in 2061, the content of H is copied to in next memory location. So after execution of this instruction, in 2060 will become 79 and 2061H will become 34H. Clear? Next instruction. XCHG. There is no operand. It is a 1-byte instruction. The description can exchange HL with DE. So the contents of H are exchanged with the content of D, and the content of L are exchanged with the content of E. It is a 1-byte extension XCHG. That means the content of HL exchange with the content of DE. To take an example, let if we have in HL, H is 8-bit and L is 8-bit, and the combined it becomes 16-bit. Let's suppose H have a 27H and L is a 65H, D have a 38H and E is a 56H. So after execution of XCHG, after execution of this instruction, the content of HL exchange with DE. So in HL it becomes 3856H and DE becomes 2765H. So it is a very useful instruction. So I'll give you a problem for a next discussion lecture. Please write down the problem. Write a program to transfer the 16-bit data from one memory location to another memory location using LHLD and SHLD. That is the problem number 1. Next problem, write a program to add two 16-bit number using LHLD, SHLD and XCHG. There is important thing, the result will also 16-bit. So it is my second lecture. We will discuss another instruction in next lecture. Thank you.